People often say that multiplying a positive quantity by a value larger than 1 produces a result larger than the original quantity. Okay, first of all, what is that saying? And secondly, is it true? Okay, I'm multiplying a positive quantity by a value. Okay, I'll call my positive quantity n. So n is a positive number. And I'm multiplying by a value larger than 1. I choose 5/4 as my value larger than 1. So multiply n by a value larger than 1. The claim is it produces a result larger than the original quantity. Okay, so let me work this out and see if it's bigger than the original quantity. See if I get a result bigger than n. All right, to do that, I'm actually going to write 5/4 as a mixed number. So I'm going to think of 5/4 as actually 4 plus 1/4. Then I'm going to see it's actually 4/4 plus 1/4, 1 plus a quarter. In which case, multiplying 5/4 by n is the same as multiplying 1 plus 1/4 by n. And then I get the little distributive rule, chopped up rectangle if you like. 1 times n is n, plus 1/4 times n is a quarter of n. Oh, I am getting n back, the original quantity, plus more. Remember, n is positive, so that's definitely more stuff. This is actually larger than n. Larger than n. Yes, it's true. In fact, I can see in general, if I take 1 plus some stuff, I'll just use the Greek letter epsilon for some positive number, multiply by a quantity, I can see I only get 1 times n, all of n, plus some extra stuff. Epsilon times n, that's actually n plus some stuff, so that's more than n. There it is in general. Yes, true, fabulous, correct. Okay, a little bit scrunchy in my board technique here, but I actually want to play now, because this is so inviting. Instead of doing multiplying a positive quantity by a value larger than 1, it seems very tempting to ask what happens if I multiply by a quantity smaller than 1. And I suspect the answer here is going to be smaller as well, so I'm wondering if that's true. So let's try that. Let's take a positive quantity n and multiply by something smaller than 1. I choose 4/5. How's that? I'll do 4/5. All right, okay, so 4/5 times n. In fact, let me analyze this exactly the same way as before. I'm going to write this as a mixed number in a way that's not traditional. 4/5. I'm going to think of this as 5 minus 1/5. In which case I get 5/5 minus 1/5. So multiplying 4/5 by n is the same as multiplying 1 minus 1/5 times n. Which means I do get 1 times n, I get all of n, minus 1/5 of n. It's all of n, take away some stuff. This is definitely smaller than n, smaller than the original quantity n. It's the original quantity n with some stuff taken away. Definitely less than. Bingo. Yes, that's true. So in general, 1 take away epsilon, some positive number epsilon times n, would actually give me, I'm going to assume this is actually not too big. I want this to still be a positive number, but I'll get 1 times n is n, take away some parts of stuff of n. This is definitely less than n. Less than n. I'm assuming everything I'm working with here is positive. All right, okay. All right, that was fun. But actually, I can see another way to play with this statement. Instead of changing the larger and smaller here, instead of multiplying, what if I change that to dividing? Dividing. Well, this is kind of fun. Dividing a positive quantity by a value smaller than 1 produces a result. Well, actually, I have no idea. I have to figure this out. Is it going to be smaller or larger than the original quantity? All right, let's do it. Divide a positive quantity, n, divided by a positive quantity smaller than 1. I choose dividing by 4/5. That's smaller than 1. Is the result of that bigger or smaller than the original amount, n? Okay, let's see. Well, right now I'm seeing fractions within fractions I don't like. I can handle the fifths in the denominator by multiplying by 5 on the bottom and then also the top to keep it the same. In which case I see this is really 5 times n on the top and 5's cancel, leave 4 on the bottom. Oh, look at this. I see this is really 5/4 times n. I am back into this situation. It's bigger. It's bigger. Back to this situation. I can now see that n divided by a small positive quantity, a quantity smaller than 1, assuming that's all positive as well, actually gives me something bigger than n. Okay, this is kind of fun. Well, I guess then the other variation is, so it's divided by smaller than 1, divided by something larger than 1. And I bet this is going to be, that was bigger before, I bet this one's going to be smaller. That's my guess. Let's find out. Let's find out. Okay, so take a quantity, big positive quantity n, divide by something larger than 1. I choose 5/4, that's larger than 1. Okay, now I'll just do it. Don't like the fourths there, so let me just fix that up by doing this. That means the top is actually 4 times n, the bottom is actually just 5, which I can read this as 4/5 times n, and I'm in this situation. Yep, a positive number. 1 minus epsilon is actually 1 minus a fifth. There's a positive number that's smaller than 1, is giving me something less than n. Bingo, that is smaller than n. True, correct. So I see here in this situation, n over 1 plus epsilon is smaller than n, assuming everything I'm working with here is a positive number. That's grand and good. All right, so some people like to sort of memorize these as rules. I find it much easier not to memorize anything, as you well know by now. I just like to do it. You actually just do whatever the problem is at hand. You actually spend the extra 20 seconds seeing your way through it, and you'll know what's going on. You'll have it clear in your mind. But this is kind of good and grand. But I actually do see another way to play with this problem. This is all about positive quantities. What if n was a negative number? I wonder how these sorts of properties change if we're dealing with negative numbers throughout this. Oh, well, that's going to be interesting to think through.